Hi, Jared. I'm hoping this will help. So, this is the picture that I showed in class today. And I showed this kind of general setup of what we've learned in class, the relationship between the marginal cost, the average total, and the average variable. Now, the price, we don't know. You're right. At first part of the problem, we used it as 40, then we could have changed it to 20, but every time we made the decision the same way. So if the price would have been at this high level, that would have become the marginal revenue curve, and we would have determined the quantity that would be profit maximizing by where it intersects the marginal cost. If the price was lower, if it was at this level, then we would also draw a marginal revenue curve, and then the new profit maximizing quantity would be right there, again, along the marginal cost curve. So every price that you can think of would give us an ideal quantity. That's how we came up with the supply curve. Now, if what they're asking for is what is the shutdown price, and we know that the shutdown price by definition is down here, right? Because if the price falls below this level, so if the marginal revenue would be lower than this, then the profit maximizing quantity is right here. And at that quantity, this is the marginal revenue, but the marginal cost, I'm sorry, not the marginal cost, but the average variable cost at that point would be above that. So let me try that one more time. So this is the quantity, this is the price. You have a MC curve, ATC, and then your average variable, right? And if I draw a marginal revenue curve down here, this is, let's say this is $10. I know that at the $10 price, this is still the best quantity that I can choose. And I will get $10 of revenue for each unit that I sold. However, my variable cost at that level of output, let's say it's 100 units, my variable cost per unit looks like it's $12, and my total cost per unit might actually be $20. So if I get $10 for each unit, but it's costing me 20, I'm making a $10 loss. Now, my variable cost out of that was $12. So if I don't produce, the difference between these two is your average fixed cost, right? So the average fixed cost in this case is worth $8. Now, what it means that if I stop producing right now, I will not get the $10. I will still have to pay $8 worth of my fixed costs, but that's my negative profit. That's all I'm going to lose because I just saved the $12 of variable costs that I don't have to pay because I never produced them. So all I'm going to have to pay is the $8 of the fixed cost. And that's a much better outcome than producing, having a $20 cost and only a $10 revenue and be in the hole for $10. I'm better off shutting down. So anytime the marginal revenue, whether it would be 10, 9, 8, whatever it would be, if it's below where the marginal cost intersects with the average variable cost, if it's below this price level, then you would shut down. So this price, this level is, let's say it's $11. This is the lowest price in this market that you would ever stay in business. You would still be losing money because the average total cost is still higher than your average variable, but at least you would cover the variable costs. So that's the story in this picture as well. I tried to sketch sort of roughly based on these numbers. This is the picture, right? So at the output of 4 units, the marginal cost is 6, and this is the lowest that we found the average variable. It goes down, and then it starts rising back up. So the lowest point on the average variable cost is at the okay, I should have probably moved the 4. somewhere down here, but what we know is that the marginal cost is not equal to the variable, so we're not exactly in this point, but we know that over here at 4 units the average variable cost is the lowest that we can see. It might be a little lower between them, but this is the lowest point on the AVC that we can observe. So that's the lowest price in this market under which this firm would stay in business. If it would drop below 16, then they can't operate, right? None of this would exist because they wouldn't even cover their operating costs. And that's the same for the break-even price. The firm would never supply unless you are on this portion of the marginal cost curve. Because if the marginal revenue was, let's say, $20, this is MR equals 20, right? At the $20, you know that the marginal cost is equal to 20 at the 5 units of output, right? So this should be 5. But this is where we'll be. At 5 units of output, what is my variable cost? Variable cost is 16.8. So this is my 16.8. My total cost, though, per unit is 32. This is this difference. This is 32. So I'm still losing money, but I am covering with $16.80. That's my variable cost, and the $20 is going to cover that and a little bit more, chipping away at the fixed cost. So the break-even price is always the lowest possible average total cost. Whatever you need to cover your cost per unit. And the lowest here that we found was this one, the 3167. So that is the lowest possible cost per unit at which you can produce. So in order to stay in business or at least break even, that's the price you would have to receive. The same for the variable. The lowest price that you could get in order to cover your costs, sorry, that was the other number, is the $16. This one. So hopefully that makes sense.